right, I'm BorisVenet. I'm here as a member of the Albuquerque Astronomical Society. And what we're going to do today is to provide a demonstration of how a basic telescope actually works. You'll see what goes on inside the telescope. So here's our setup right now. What we have over here is a simple refractor telescope. That just means that it consists only of lenses. And there are just really two optical parts in this telescope. One is a lens inside this little short plastic tube here. This is the lens through which the light goes first. And then there's a lens on the back of the telescope here, which is called the eyepiece lens, because of course we look through it with our eye. This little screen here right now, you can see there's just a hole in the middle of this screen, and you'll see what the purpose of that screen is in a minute. So what we'll do first is we'll show, let me say a couple of other things first. So the main difference between this setup here and a telescope that you really look through is that there's no tube that hides all the parts. I mean, the tube serves a couple of purposes. It keeps everything aligned and rigid, and it protects the optical elements, the lenses in there. But in order to see what's going on, we just break it all up into its basic pieces and forget about the surrounding tube. Okay, so let me just show one of my eager students here what the telescope optics actually consist of. It's a little bit hard to see the lens inside the tube because it's a little bit hidden by this plastic tube here. But I have another lens which is almost exactly like the lens that's inside this tube. And this is the one here. Usually I have people kind of feel this lens. Normally you don't want to put your fingers on an optical element in a scope, but for these demonstration lenses it's perfectly okay. And in fact, can you feel that the surface of the lens, the flat, I mean this surface here, it's perfectly okay to put your finger on that. Can you feel that it's not exactly flat? Does it seem?
Yeah, it seems like it's dome-shaped almost.
Okay, it's curved outward just a little bit.
Okay,
Right.
that's understandable.
So that's the main characteristic. I mean, that's what makes it a lens instead of just a flat piece of glass, like a window pane.
And it's like a magnifier?
It can function as a magnifier.
Okay.
That's right. As a single lens, you could use that as a magnifier.
Okay.
So that's really all that's in this first element of the telescope here. And then the second element, that eyepiece lens in the back here, that is different in one important characteristic compared to this. Here's a loose version of what the eyepiece lens back here is. Take a look at that, and feel across that, and maybe tell me what you think is the main difference in how that feels compared to the first lens.
Where the first lens seemed more dome-shaped, where this one seems more fulfilled throughout, where the areas are more dome-shaped. It seems...
Okay, it's more, in other words, the term that we would use in optics is it has a greater curvature.
Yes.
It's more curved.
Yes,
and
it's
you
more
call it
curved.
dome shaped, which is perfectly reasonable.
And it's actually thicker than the other lens.
That's right. The thickness itself isn't really important. It's just that if the lens is a certain size, then if it's more curved, it has to be thicker.
Oh, okay. Oh,
So
wow.
that's really, the thickness is kind of an accidental part of it. But it's the fact that that surface is more curved.
And with the first lens, I was able to see through it a little bit more than this one. Is there a difference?
I think that's just because if you hold it at different distances from your eye, then you'll see that that one could be used as a magnifier too.
Oh, okay. I actually can see that. Oh, wow. How cool.
Okay, so that's just a hands-on way then of seeing what the main difference is between the eyepiece lens and the first lens, what's called the objective lens. That eyepiece lens is much more curved. And that's really the only thing that distinguishes the two
Yeah,
lenses.
how cool.
So, okay, so now we've seen more or less what the kind of lenses are that are used in the telescope. And now what we're going to do is we're actually going to follow the light beam as it comes from some source that we want to look at. We're going to follow the light beam as it goes through the telescope and see what happens to it.
Okay.
So over there, in this case, just about 20 feet away, we have a flashlight, and you can see from here, just with your own eye, you can see that there are actually several little LEDs inside that flashlight.
Yes.
So that'll be a convenient source. That'll be like our multiple star system out there.
In our new normal.
And that's right. So now we'll see that first the light, of course, comes away from the object that we're looking at. That light's spreading out, and some of that light is going to go through this lens here. And now by using a little, just a paper screen, we're going to see what the light beam looks like after it goes through the lens. So first, I'm just going to stick the card in here, and you see now that there's, just behind the lens, there's just a kind of fuzzy circle of light
Yes.
coming out. Now what we're going to do is to follow what happens to the beam as it moves through the telescope. I'll just pull the card back, and now you see the key thing that's happening. The beam is getting more and more narrow.
Which is to exemplify the inside of a telescope.
Exactly, exactly. So that beam that spread out from the light source is now being brought back together by this lens, or it's being focused. That would be the technical term.
Okay.
And so we see that it gets gradually narrower as we move a little bit further away from this lens. And now, after it reaches a certain point here, and this is where I put this little metal screen, now I'm just going to stick a card in here so that we can keep this stationary and see what happens.
Oh, wow.
Now, see, if you take a close look at that, it's not just a tiny little dot, it's actually a little image of that
Of
light.
the light.
Right, you actually see again all the little LEDs in there.
Yeah, you do. Dot, dot, dot.
So that's the first thing that happens in the telescope then. It forms this first optical element here, this first lens, forms a tiny little image inside the telescope.
Uh-huh. And is there a name for that process?
Well, it's called forming the primary image.
Okay. Forming the primary image.
And now, by the way, if this were a camera, if this screen here, instead of being just a paper screen,
Yes.
if this were the kind of electronic sensor that's inside a camera, then this would be what a camera is doing.
Oh,
So
okay.
this is a very simple camera lens here.
Oh, nice.
Usually camera lenses are more complicated, they're made out of several different lenses, but that's all kind of a refinement on the basic process.
Okay.
Essentially what the camera is doing is just forming a simple image like this, only the screen here is this complicated electronic sensor that's sensitive to light, converts it to electricity and stores it so that you can replay it and all of that.
Okay.
So now, that's the first part of what goes on inside the telescope then. This tiny little image is formed there. Normally everything's surrounded by a tube and you don't see any of that neat stuff going on inside here. So now what we'll do is we'll just move this card out of the way, and you see where the image was, there's just a hole in the screen.
Right.
So that light is just going to keep going now.
Okay.
And I'll move the card out of the way so that maybe the camera can get a slightly better look at what's going on. This is a little more difficult to see now just because the space is a little bit tight in here. But you can see that if I put the paper card in here, if I keep moving the paper card back, you see the beam's getting a little bigger again now.
It does.
So the beam was focused here, it came together, and now it's spreading apart again. Oops, I have
Go
to
back
keep
up.
this aligned. There we go. Spreading apart again. And now it comes to the eyepiece lens of the telescope.
Right.
And so now what we're doing is, if you imagine this little image that was here that you saw on the screen, the light is spreading apart from that. You can think of that little image there as being the new object, so to speak.
Yeah.
So this second lens here, this eyepiece lens,
Which is the thicker one.
the thicker one, right? It's doing just what you described before. It's going to act as a little magnifier now for looking at that primary image. And so if you look through here, and I think the seat here is at a more or less comfortable height. If you come back here and now look through the telescope the way we would normally do, you see a magnified image of that flashlight over there.
And then the flashlight, you can actually see that there's 2, 4, 6, 7 lights back there.
Right, right. So that's the final magnified image then that you are seeing when you look through a telescope of this kind.
Interesting. Interesting.
And in fact, here's one somewhat cool thing that you can do.
Tell me.
Normally, this you can do here because everything is kind of small and doesn't have a large tube surrounding it. So you have the opportunity to do this. If you take a seat here so that you can stabilize yourself, and see if you can look through the lens here with one eye, and if your other eye is off to the side, you can use your other eye to look directly at the light source. And you can see the unmagnified and the magnified image at the same time.
I can. That's so weird. And so neat at the same time.
So that's kind of an interesting way in which you can see just how much it's magnifying. When you only see the magnified image, it's kind of hard to go back and forth and try to remember, oh, does it look like about 5 times as big or 10 times as big or whatever. But if you see them both at the same time, you can get a better sense of how much magnification there is.
And with this type of telescope, what would you generally look at? Everything or
Well,
Specifics.
these are, normally, since we're from the Astronomical Society, we normally use the telescope to look at things in the sky.
Yeah.
The moon, stars, galaxies, if you're in a dark area, so that there's not too much city lights. But really the same kind of telescope could be used to look at things on Earth too. Of
Okay.
course,
Birds.
sailors always use them, to see ships in the distance.
Yeah.
And for terrestrial reasons, you can use them. Binoculars are just two of these side by side, so that
okay.
you look through both eyes at the same time. Each eye is looking through a separate little telescope, actually.
That's
So the
neat.
principle is always the same, though, in all of those systems.
That's good to know. Good to learn.
And so that pretty much concludes this demonstration. And I just, might be worthwhile to just very briefly review the basic items. One, what does it consist of? There are just two lenses here, an objective lens, an eyepiece lens. And the way the system works is that the first lens here formed a little image, which is normally hidden inside the telescope. Then, when we look through the eyepiece, the light that goes away from that first image goes through the eyepiece, and you use the eyepiece as a magnifier, just like the magnifier you'd use to read small print.
Sure.
And so it's the combination of those two lenses that produces the final image that you see, the final magnified image.
And how long have you been doing this?
This particular demonstration, you mean?
No,
Or
just
optics? Well,
Optics, yeah.
I studied optics and, worked in that area professionally.
Oh,
So
wow.
I've been doing this kind of thing for a long time.
Oh, nice.
I won't say how many years.
Okay, I won't force you.
Yeah, very good.
Thank you.
You're
Thank you
welcome.
very
Thanks for being such a good audience.
much. Yeah, I like to learn.
Okay, so we're back now, and we're going to demonstrate a different kind of telescope. The one we demonstrated before was called a refractor. It consisted only of lenses. This time we're going to demonstrate one of the other basic, most important kinds of telescopes called a reflector. And this one is different from the refractor in the sense that it uses a curved mirror plus some lenses also. So here's the basic setup of this reflector telescope. At the back of the telescope, there's a mirror here. And this kind of mirror, it's not a flat mirror, but it's slightly curved. You can't, it's difficult to see because the curvature is not very great, but it's slightly curved inward. We call that concave. And in fact, many people have this kind of mirror in their bathroom. A makeup mirror or a certain kind of shaving mirrors.
Mm-hmm.
They're exactly like this. They're bent inward a little bit. And so you can use one of those mirrors to make a telescope of this kind. Then,
Why is that?
pardon me?
Why is that?
Well, in order to fully explain that, you'd have to study a little bit about how rays bounce off the curved mirror.
Uh-huh.
You're familiar with a regular flat mirror.
Yes.
You see an image in there, and it's the same, basically the image in that kind of mirror is the same size as the object. You don't look magnified in any way. But if you make the mirror curved, then you can generate an image that's a different size. You can get magnification.
Oh, nice, okay.
So that's one difference between the curved mirror and the flat mirror. So that's the first element in the telescope, or to be a little clearer, it's the first element that the light hits in the telescope. It's at the back of the telescope, actually, as you can see. Our source is over there. So the light is going to come in from the source over there. It's going to come in and hit this mirror, and then the other parts of the telescope are here. This is just a little flat mirror now. It's very small, and there's a reason for that. We can talk about that in more detail later. And you can see this mirror, this little flat mirror, it's tilted at about a 45-degree angle. And so the beam is going to come off of this mirror. It's going to hit this little flat mirror. And then you can see, because of the angle of that mirror, beam is going to come off here and go out sideways now. And here's a lens. This is the eyepiece lens. And this is going to function in more or less the same way as the eyepiece lens in the refractor that we worked with previously.
Okay.
So now the first thing we're going to do is we're going to use the card again and follow the beam of light as it moves through the telescope and see what happens at different places inside the system. So again, our object is that flashlight over there. That'll be our multiple star system. And now using the card is a little bit trickier here because we have to avoid getting in the way of the light beam. So the light beam comes in from the front here, comes through the telescope, hits this mirror. Of course, it's going to bounce off of this mirror. And now by putting the card in here, we're going to see the beam. Now, of course, we have to look at this face of the card here now. And you see, as we move the card away from the curved mirror, see again, there's a beam that's getting smaller.
Yes.
And so now we're moving the card again away from the curved mirror. And we can see that the beam is getting narrower. It's being focused, in other words. At this point, we've lined things up so that the beam strikes this little flat mirror that's tilted. And so the beam is now going to bounce off in this direction, off to the side, because this little mirror is tilted. And if we come around the other side, then we'll be able to follow the beam as it bounces off the little mirror here. I have to get out of the way though. So there's the beam as it bounces off the little mirror. And now I keep moving the card further and further away. You see the beam gets smaller and smaller. And at this point, right about here, you again see a small little image that's formed of the light source. You can see all the little individual detail inside the source. And if I keep going even further away, that beam spreads apart again. And then as that beam goes through the eyepiece lens, that's what we're looking at with our eye. And so we look through it, and we're going to use this lens as a magnifier to examine that little image that's formed here.
Oh, okay.
So if you come around, and now this is the way that you would use the telescope. If you look through there, get your eyeball lined up with the center of that lens, then,
I see all the little lights.
right.
How neat.
So what's peculiar about these kinds of telescopes is that you look in the side. Here, you know, if this were a real telescope, then there would be a big tube surrounding all of this. This lens would be sticking out the side of the tube, and the reason you look into the side of the tube to see the beam is because of what we just showed, the way the beam bounces around inside this telescope.
I like that.
So that's the principle of a reflecting telescope. And that pretty much concludes the demonstration. Just as a reminder, the way this works, although it looks very different from the refractor that we used before, the principle is very similar. It forms a little primary image, that tiny little image that we saw here inside the telescope, and you use the eyepiece lens to form a magnified image of that. The only difference is between this and the refractor, the difference is that we used a mirror, a curved mirror in this case, to form that primary image. So that is the second main type of telescope.